Hello, this is Miss Dagan Ford, and we're going to learn about our light independent reaction. And this is on our Google Slides, and make sure that you've updated. And after this video, we're going to do some practice. We're going to draw one, and you can feel free to use a piece of paper, but I would suggest you do that after we do it on the Jamboard. But if you are wanting some old school learning, my dog wants to eat his supper. Um, if you want to do some old school, grab a sheet of paper, then that works too. So this is going to be the second stage of the light of the photosynthesis, the light independent reaction. This is happening in the stroma of the plant. And the goal of the light independent reaction is to make some sugar, some glucose. That's been the goal all along, but we haven't seen it yet. We saw ATP, we've seen ATP, NADPH, but we haven't seen glucose yet. And so this is going to be what happens in our light independent reaction. Now, I want you to think about maybe the last time you have seen somebody bake a cake or cupcakes or cookies, whatever, because that's going to help you visualize what's going to happen. When you cook something, you got your ingredients. So you might grab some flour, some chocolate, cocoa powder, some sugar, some eggs, whatever else you need to make your cake or cupcakes. But you know inherently that just mixing the recipe together, ingredients together, you know that inherently doesn't actually make a cupcake. What you have to do is add the heat in the oven. And so notice that's what we're going to do. We've got our ingredients, but we then have to add energy to the process in order to create a reaction. So we've got three major steps to this. And keep in mind, think about making a cake. You've got your ingredients. You're going to use some of those ingredients and bake it. And then you might put back the ingredients that you didn't use. And so that's going to be kind of a helpful thing to think back. Now, one thing you need to know about the light independent reaction, it is very slow. It's and it needs a lot of energy. Imagine a big boulder at the bottom of a hill, and you need to push it to the top of the hill, and that needs energy. And so, from a reaction standpoint, this does not want to happen. This is not a reaction that is spontaneous or happens with ease. So, we need to do some things to speed it up. And one thing you actually know about, and that is that it has a high activation energy. And if it has a high activation energy, we need something that can lower the amount of energy. And I'm hoping in your mind, you're like, wait a minute, that sounds familiar. You need something to lower the activation energy and increase the rate of a reaction to speed it up. Do we know something that speeds up a reaction and lowers activation energy? Enzymes. And so what we have is an enzyme that we're going to talk about, very, very important enzyme. And it's been estimated to be the most abundant enzyme on the earth because, well, all plants photosynthesize, and so they need this enzyme. So here are the three major steps. We need to grab carbon dioxide from the atmosphere. And we're going to grab it and add it to the plant mass. So we're going to add carbon dioxide, grab it to a molecule that the plant already has. And it's a 5-carbon molecule. And we'll identify what its name is. But that's the first step. Get carbon dioxide out of the atmosphere and into the plant. The second main step is to add some energy, and that's going to be the energy in NADPH and ATP, and that's coming from the light dependent reaction. And so they've got the hot electrons. NADPH has electrons from being energized by sunlight, and ATP, which the light dependent reaction made. So just like baking a cake, you're going to add that energy and you're going to get some glucose. Yay. And then there are going to be some ingredients that you haven't used and or you need to recycle, and so you're going to recycle the ingredients and then start over. Uh, so let's go ahead and show you. Now, this diagram has a little bit more detail than we need, but I will say it's super, super well done, and so we can kind of use it for ourselves. And let's see if we can identify the steps. So the reason it's called the cycle, the Calvin cycle, is because we're going to end up in the same spot. So here's going to be our 3 carbon dioxides, and we're going to add carbon dioxide to these 5 carbon molecules. Now, these 5 carbon molecules are called RUBP. Don't worry about what it means. I'll tell you in another video, but you just need to know them as RUBP. So we're going to actually connect them here. And to prove it, let's count. Let me get my pointer here. So let's count. We've got 1, 2, 3, 4, 5 carbons. We're going to add a carbon from carbon dioxide. 1, 2, 3, 4, 5, 6. So the plant has been able to attach that carbon dioxide, and it's going to make food from it. Now, just to reiterate, we need an enzyme to do that. So here's our carbon dioxide, here's our RUBP, and the plant's going to connect them together. We need a lot of Rubisco to make that happen. And so they get connected together. This molecule doesn't stick around too long. They spontaneously break down into something called PGA. Yeah, I'm going to tell you what it is, but I'm actually not going to need you to know that name. I'll tell you what you need to know. You need to know RUBP, that 5 carbon molecule. And what ends up happening is this is the baking part. We're going to add energy, ATP and NADPH with its hot electrons. We're going to add the energy in, add the electrons and hydrogen in, and they came from the light dependent, and we're going to cook, we're going to change these molecules. Now, unfortunately, with these diagrams, they kind of, in order to make them simple, they oversimplify sometimes. In other words, you're going to look at these and say, nothing happened. There's 3 carbons, and there's still 3 carbons. But what you're not seeing are hydrogens and bonds being changed. Suffice to say, what we make is something called G3P. I want you to know that name, G3P. We are making G3P. This molecule is basically the starting point for making glucose. A plant needs 2 G3Ps to make glucose, which is a 6 carbon molecule, C6H12O6. So we're going to do the cycle twice to get another G3P out. And then we've got some G3Ps left over. We're going to recycle them back and start the cycle again. And that can seem a little redundant, but remember, this is a very slow reaction. We need as many as we can to get this started. And so you don't need to see that. You'll be seeing just a couple of videos to help you see what happens. And then you're going to build this cycle yourself with the jam board. So I hope this gave you some helpful information. And now it's time to practice.